Hello, and welcome to the Satellite Image Deep Learning Podcast. I'm Robin Cole, and it's my pleasure to present another technically focused episode in the series. In this episode, I caught up with Alistair and Miko to learn about Major Tom, which is a significant new public dataset of Sentinel-2 imagery. Noteworthy for its immense size at 45 terabytes, Major Tom also introduces a set of standards for dataset filtering and integration with other datasets. Their aim in releasing this dataset is to foster a community-centered ecosystem of datasets open to bias evaluation and adaptable to new domains and sensors. The potential of Major Tom to spur innovation in our field is truly exciting, and I hope you enjoy this episode. Hi guys, welcome to the podcast. How are you?
Hey, good to see you. Very well.
Right. So really excited to hear about what you've been up to. Why don't we begin with just a quick intro to where you are and what you're doing. Over to you, Alistair.
Yeah, so Miko and I are both research fellows at the Phi Lab in Esrin, in Italy. And we're sort of working on a bunch of different projects related to representation learning across big data, kind of data-centric ML, some generative stuff on Miko's side as well. And we're kind of we were just really motivated basically to help all of our projects and the projects of our colleagues at the Phi Lab, and also hopefully the projects of others outside the Phi Lab with some sort of high quality, just baseline data sets that people can plug into for kind of big data applications with EO.
Right. And so what's this new data set that you're announcing?
Yeah, so Major Tom is so it stands for Terrestrial Observation Metaset. And it's both a data set that we're going to sort of talk about today, that we've released today, but it's also a kind of wider project that we hope to build with the community. So currently it's Miko and I have just been working on it, but we're kind of hoping to engage people both through this podcast and through the data set itself to build a kind of whole range of data sets that can be used kind of like building blocks together, and that you can piece them together and filter them and combine them to kind of generate multimodal data sets or generate data sets over specific places and times with a sort of rich time series, or any other kind of application where you can imagine like combining data across different data sets. So the data set that we're sort of releasing today is so-called Major Tom Core Sentinel-2. And we think it's the largest Sentinel-2 data set that's yet been released for kind of ML applications. And it's about it's about 45, 46 terabytes of data across the two levels, covering about half the Earth and pretty much all the land. There's a few missed areas where we couldn't get a good scene, et cetera, but for the most part, all the land is covered. And we have about 2.5 trillion pixels in the data set. If you think about it in 10 meters, obviously there's all the bands. Mm-hmm. And our kind of design principle was to do as little to the data as possible. So the data is in its original pixel values. It's not resampled. It's not reprojected, which has pros and cons, which maybe we can talk about later. But yeah, that's the data set, and it's hosted on Hugging Face, which I think is maybe not a first for EO data, but it may be a bit of a first for a kind of really big EO data set to be hosted in this way. And again, there's pros and cons with that. So there's some really, really nice functionality that we can do that we can show you later in terms of streaming data, in terms of sampling it from the cloud, like from the Hugging Face repo. And it also offers like very fast download if you just want to download the whole thing. Mm-hmm. So yeah, that's the kind of broad picture, the broad overview. Miko, do you want to add anything?
No, I think that all makes sense. We're basically trying to build some more organized effort in building the next generation of EO data sets. And we will definitely be following these rules to make sure most of the data sets that we create are kind of compatible with each other, and we can kind of mix and match these data sets. And Core is really exciting because, something I always struggled to find was a nice kind of agnostic large bulk of Sentinel-2 data that I can kind of prototype on. And I think with Core, we really have achieved that. You can basically make any subsets across the entire Earth and capture the area of interest, or maybe just sample uniformly across the Earth. Mm-hmm. So it's kind of up to the user what they find interesting, whether it's urban areas or something completely different. I feel like it's quite it's not very flexible to kind of work under the assumptions that the dataset designers always have to make about what areas are being sampled over the others.
Right. So I think that's, as you mentioned, kind of I guess, limitation of existing data sets. They tend to focus on North America or some specific continent. And obviously, we want models that work over the entire world. So it implies you need a data set over the entire world. And I think the really interesting aspect for me is that you mentioned this will be a core data set and it will be able to join on with other data sets. What are the considerations to make that possible then? I suppose you need geospatial imagery for a start.
Yeah, so we have a kind of few like building blocks that I think will also kind of reify a bit more as we see more data sets added to the space, because we kind of come up with some specifications, and I'm sure the specifications will break in a few data sets time when someone comes up with something quite different. But for now, Major Tom, like the central component of Major Tom is the grid system that we have, which basically is like an index for the samples. And it's not hard to get data over the same place from different instruments if you want to. But what's annoying is dealing with different extents and different overlaps and trying to find kind of consistent windows of interest across all of these different scenes and different products. So basically what we've tried to, and different data sets, right? So what we've tried to do is basically just say, here's like a pretty good kind of all-purpose grid system for the world, which is basically concentric rings around the Earth with 10-kilometer spacing on each row. And then we do a kind of integer divide of the circumference at that point to get to as close as possible to 10 kilometers grid spacing round. So there's no kind of nasty, weird overlapping areas at the date line or at the zero line or whatever. It's all just kind of evenly spread 10 kilometer by 10 kilometer grid squares with a kind of easy to understand indexing system with up and down and left and right from the 0 point. So with that, what we're just hoping that people do is kind of just follow that system and put their data in these little pockets, with sort of understanding that if you're putting data there of like a raster image from a satellite, then you try and sort of make sure that it covers most of that area without excessive no data values. We have some no data values because obviously sometimes you sample in a place where there is no Sentinel-2 scene that has like full data across the 10 kilometer by 10 kilometer grid. So it's inevitable, but we kind of, best estimate. And alongside that, currently we have a kind of metadata specification that is now probably a bit too specific for like the general purpose thing in the future that we envision, but we're kind of going to build up the specification as we go. And that metadata is, the grid cell it's in, the time it was taken, the product ID, in the case of Sentinel-2, cloud cover, no data, things like that, in a big metadata table that you can download without having to download all the data. And it also contains basically the link to the file in which you'll find that data. Because on Hugging Face, we're using so-called Parquet file format, which is maybe a bit unfamiliar to people in EO. And it's maybe a bit of a learning curve, but it's basically a column-based table format, which is good for kind of holding really large amounts of data. So there's like 5,000 Parquet files, each 5 gigabytes big, each containing about 500 samples. And so to access a specific sample, you kind of need to know like which Parquet file it's in and where it is. So maybe this is a bit specific to this data set, and maybe we'll come up with a kind of more general way of interfacing with different Major Tom data sets. But the kind of conceptual framework is that we're going to be putting it in this grid system, the Major Tom grid system. And that kind of just ensures that across different data sets, if I say grid cell 512 up, 32 left, which I don't know where that is, maybe it's somewhere over Portugal or Ireland or something, then everyone knows where the data is that I'm talking about.
Right. So grid system, and I suppose obviously indexed by time as well.
Yeah.
Right, okay.
Yeah. I mean, if relevant, right? You can imagine data sets where maybe like a digital elevation model, you don't really need time, but where it's relevant, obviously.
You briefly mentioned the Parquet format. Obviously, there's geospatial formats for indexing data. Stack is an indexing format that's getting a lot of attention. What are the considerations?
So I think that's one other thing I forgot to mention is we are actually looking at sort of stackifying what we've done so far and kind of encouraging others to do that as well. But I don't know if you've worked with Stack, but it's maybe a bit easier from the user side than it is from the server side to kind of generate this metadata for all of the different files that you're using. So we're kind of working through that at the moment, but it will be done. It's not like a sort of pressing concern because I think the really good stuff about Stack is going to come when you have this whole ecosystem of different data sets that you can, filter and play around with within the Stack search. So.
And of course, you've got platforms like Planetary Computer where they have a stack index. So you can imagine, say, I've got my XYZ data set, let's join it with the imagery here, and then we'll do some pre-training on the entire data set and maybe some fine-tuning over a specific geography, something like that. Really interesting stuff. Cool. I'd love to hear about the practicalities of working with this data set. Obviously, 46 terabytes is kind of a massive data set. Nobody's going to unless they've got a huge machine, download it locally. How do you anticipate people actually working with this then?
Yeah, it was hard enough building the thing. We annoyed several very, very brilliant and patient engineers that helped us with the kind of compute side of this, and we were constantly running out of space as we went and things. So kudos to the team there. The key thing is that, there's kind of two modes of operation, right? You can search and filter the data set very easily using the kind of metadata table that's only 200 megabytes or something like that big. And you could say, right, I'm going to take all the images over France. You get a polygon for France or a bounding box, and you quickly search and filter, and you say, okay, I don't want cloud cover above 10%. We never have excessive cloud cover, but we have a bit of cloud sometimes. And then you sort of might end up with a few hundred gig data set, and you can use that how you want. The other option, of course, is just downloading the whole thing. People are going to need disk space if they want to do that. I'm afraid they could try to do some kind of streaming approach to training because Hugging Face does allow that. We're kind of doing our own testing at the moment, and it seems pretty good for doing it for streaming in order, but we're not sure quite yet how we get kind of good performance on like a shuffled streaming. So these are kind of questions, open questions, I suppose. But ultimately, if you want to use the whole data set, you're probably going to have to fork out some terabytes of storage to do so.
Really interesting.
We have some.
Sorry.
We have some notebooks already set up. So if for anyone who's interested in this aspect, there's a Colab notebook where you can actually take this basically for a spin and filter your own version of the data set, download it, and basically immediately incorporate it into your PyTorch framework. We're still kind of investigating how we can fill the space between like downloading your own small copy and downloading the entire copy, and obviously streaming can sometimes satisfy this context, but we might still need to do a little bit of work in terms of the framework to make sure that it's kind of easy enough to work with and fast enough for actual training of deep neural networks.
Yeah, you mentioned that the datasets on Hugging Face. I've not got any personal experience of streaming off that, but obviously the streaming bandwidth is going to influence how effectively you can utilize whatever GPU hardware you've got. And potentially there's different considerations whether you stream it from platform A or move it to platform B and stream from B. Do you have any kind of data on costs and bandwidth available?
We'll see in the demo, but we found that the download speed from Hugging Face is pretty good. It's probably not at the kind of speed you need to create batches and like fully maximize a GPU during training, right? You're probably going to have some downtime between batches if you're like fully just streaming it. That being said, to just like kind of navigate and search through the data and filter it, it's pretty responsive. Yeah.
Fantastic. Sounds like just an engineering challenge then to get the maximum utilization. Really exciting stuff. Thank you so much for the overview. I want to briefly move on to downstream models and the state of the art at the moment. There's lots of interest in foundational models, and obviously data sets like this are used in the process, the training of those kind of models. I'd love to hear both of your thoughts on where the models are at the moment and where you see things going.
Yeah, I mean, I think there's some really exciting stuff going on. I think a great example is a previous guest of yours, Konstantin, who was talking about Saclit. That kind of global approach, really big data set that he was using. I think he said it was 100,000, 200,000. Yeah. So I mean, obviously, we're kind of beginning to see this like scaling up of approaches to big data. I think what we're really kind of concerned about, or we want to help encourage, is that these models that are, I don't really like the term foundation model, but let's say foundation model, that's going to be used in all of these different applications, in all of these different areas by all different people, with greater or lesser understanding of how the model works or what the model is doing. I think what we think is really important is basically that we have kind of data provenance, and we have an idea of like, okay, this model, we know what went into it. We know it's relatively unbiased, hopefully, because it's globally distributed. It's not just over Europe and America. Mm-hmm. We can trace the training data that they used to the kind of model output, and we can recreate it if we have the resources, and if we have the inclination, we can reproduce that step. And so Major Tom is kind of trying to be as generally useful as possible to all these different applications and all these different kind of ways of thinking about representational learning or self-supervised learning at a large scale, so that we can inject some kind of traceability into all of this work that's happening now. Because I think what we want to avoid is maybe something that we see more in large language modeling, where, okay, there are amazing things going on in the open source world there, and there are amazing data sets out there as well. But, the kind of the people at the front of the field are basically, competing with their proprietary large data sets and their massive computational resources. We can't really fix the computational resources part yet, but we can at least make sure that in EO, the best data sets that are out there are openly available, traceable, understandable by everyone, accessible to everyone, and relatively unbiased. Yeah. And where they are biased, we can at least understand that as a community, and it's all out in the open. Mm-hmm. So, yeah, I think we're really excited about all of these kind of big, let's say, foundation models that are coming out, but we really want to encourage the community to kind of think more about how we make sure that they're not just are they open, but they're also sort of traceable in the sense that they have data going in that we understand, and so we can understand then maybe better how they're performing and why they're performing in certain ways.
Yeah, so we don't want just sort of black box solutions, and want to be able to audit the data, understand the bias potentially, and obviously this is where you're leading, that data sets can change over time. You might address imbalances in the data, for example. Sorry, Miko.
I think a lot, like an important context here as well, is not only whether we can access the data, but how easy we can access that data. So like Copernicus is an amazing program, and we've got tons and tons and tons of data. And everybody keeps recreating data sets for their own purpose. Sometimes they're open, sometimes they're not. But in essence, like if we want to create something quite general, it's not just a matter of like providing like supposed access to everyone who can go through the entire process of acquiring the data from an open program in one way or another, and then doing what they want to do to basically utilize that data. We also want to actually make it really easy to use if we want these models to be traceable. And Major Tom tries to do that for Copernicus. I mean, Major Tom Core is what it tries to do that for Copernicus, but we could do it with all sorts of data sources. I think like there's this, like we're basically trying to fill that big gap between huge data archives of EO imagery and data sets that we use for deep learning, because there's still a big divide. And I feel like these two communities are slightly isolated in some sense. And these it seems like there's still quite a lot of improvements we can make for like creating a bridge between these two contexts.
Yeah, I mean, if I totally agree, and like if we go back to the analogy of language, there's a kind of great irony that for large language models and also like image generation models, the secret sauce, the proprietary information, if you like, is the way that these companies search and filter through the vast quantities of actually public information that is out there on the internet and in other sources. And this is all information that is accessible to everyone all the time if they have the inclination to go and find it. But the difficulty is kind of searching, filtering, paring down that vast trove of information, deduplicating whatever, into something that can be maximally useful for training their model. And actually with EO, we see a really similar thing, right? We have this huge trove of public information from these publicly funded programs, Copernicus, USGS and NASA in America and others. Like we saw great things with like the Indian Space Agency releasing quite a large data set recently, I think. So we want to kind of do that searching and filtering and paring down for the community to make sure that everyone has access to kind of a high quality, unbiased data set. And we don't end up in the situation of large language models and image generation models.
Yeah, I think it's really great that you're taking the lead and also just raising that issue, because, things move so fast with language models. It seems almost like a retrospective to try and unpick that problem. Very finally, I just want to understand the evolution and the ownership of this data set. Is it something that's going to continue to grow under your direct stewardship, or does the team own it? Does the organization own it? Who will be managing it in 5-10 years' time?
Well, currently, I mean, it is just me and Miko who have been working on it, and we've kind of kept it fairly close to our chests until now because we kind of wanted a bit of fanfare with this release. But I think we're both really, really keen to understand more about what the community wants and welcome absolutely anyone who has an interest in helping to build these Major Tom datasets. And really, so there's a Major Tom organization on Hugging Face right now. We have a GitHub that's hosted by the ESA Lab on GitHub. But from a broader, and anyone can kind of request to join, and we can definitely accommodate that. But from a wider perspective, there's nothing stopping someone making a Major Tom compliant data set outside of those organizations, right? It's still the same format and specification. But we will be looking, I think, if we generate kind of a big community of people who are interested in some kind of structure by which we can maybe make decisions, about the format in a sort of democratic way, how we actually want to structure these data sets, how we want them to interoperate. And that really can only come from a large number of people, because we are ultimately just going to think about applications that are relevant to us because we don't know about other applications, right? And so if people come with all sorts of ideas about what this could be used for and how this could be engineered, then I think it will be a much richer system for it. So we're yeah.
So there's the cool tales.
Yeah, I just wanted to reiterate that we really want people to join Major Tom, because there's quite a few ways of contributing to the project. Because like even right now, just by running the filtering notebook on your own machine, you can kind of create a subset of Major Tom that works for you and maybe for some other people. So you can actually create a sort of new dataset definition with very minimal effort and publish this as a subset of Major Tom that works for this and that. Then obviously even more interesting will be if people decide to contribute with new data samples and also with new labels. So I mean, so far we've been quite focused on self-supervised and generative applications. So this is just like a large bulk of input images, so to speak. But labels are quite interested to many people working with EO data. So we definitely want to find ways how we can also kind of join forces and create richer data sets and maybe mixes of data sets that also involve labels. And I think this is really interesting because if we have like labels that don't change with time as much, we can actually elevate other data sets to help us with various tasks. And like spontaneously, we can sometimes maybe get like temporal series and whatnot just by combining different sources. So it also like we're really waiting for a response from the community regarding like what's most interesting to them and what's most useful. And we can go in quite a few directions. We're going in quite a few directions already by developing extensions ourselves, but will definitely be like the following contributions will definitely be based on what people actually tell us they're looking for, and maybe they will want to join the forces and actually contribute actively to that.
And the most pressing issue is that our hard drives are full, so we definitely need help from other people because it's getting harder and harder to collect more of this data. So we need to help us guys.
Yeah, there's only so many drives available on Amazon, and awesome. Well, once again, thank you so much for the overview of the data set. Really exciting, really looking forward to seeing how the community grows around this. Sounds like Hugging Face is the prime location to connect with the data set and yourselves. And I'm really looking forward to future updates.
Thank you.
Thanks.
In the following short video, Alistair and Mikko demonstrate the app designed for navigating the Major Tom dataset and provide a walkthrough of the Jupyter notebooks used for filtering and saving subsets of this massive dataset. For those looking to begin working with the Major Tom dataset, this video is a great place to start. Hi Mikko, so looking forward to a demo on Major Tom. Why don't you kick us off?
Okay, great. So I think we'll start with the Hugging Face organization of Major Tom. This is basically the kind of the meeting point we hope that where people can basically contribute, share their ideas, and coordinate the creation and publication of different Major Tom datasets. So that's basically it. So far, we have two datasets. The core S2L2A, which is level 2 Sentinel-2, and L1C, in case anybody is looking for any of the two specific levels. I think that's an interesting point as well. There's quite a lot of L2A datasets being currently used, but very often we found that for some samples, L2A has certain distortions that people might want to avoid, and hence maybe resort to L1C. So we found that we basically want to provide as agnostic as possible the data set of Sentinel-2 data. There's a manuscript here as well. If you're interested in like reading about the journal Vision on Archive, there's a manuscript that basically outlines our vision for the Major Tom data sets. And that's about it. There's also like a cool app where you can basically quickly check whether an area of interest is in Major Tom datasets. And very likely it will be. So we can go basically any point. I mean, we could try Rome, but effectively we can go across any point on Earth that's captured by Sentinel-2. And here's Rome. So far, so like core basically contains a single sample per patch, and we can like really go almost anywhere. We can go to Greenland, and most likely a patch will be there. Oh, it really worked. Okay, so if anyone wants to just give it a go, they can quickly get that, go to that space in our organization. It's basically an app that's hosted on Hugging Face constantly.
That's cool. Is that like a Streamlit app or something?
I really wanted to make this a Gradio app, and I hope like eventually Gradio kind of like dynamic bidirectional components will be possible. So far they're not. So I used Solara. I actually asked. There's one person who's been really active in this area, the author of LeafMap, Chisheng Wu. Mm-hmm. I asked him about his ideas because I saw him creating a lot of apps on Hugging Face. With LeafMap, and Solara, which is another type of library, seems to currently work best. It still requires quite a little bit of effort to create that and tinkering. So I hope like we will be getting easier and easier ways of creating geospatial apps on Hugging Face in the near future. But so far, it's a little bit of an effort to make something like that.
And that's maybe another area where somebody with some specific expertise might contribute. And I think having this really large data set makes it a particularly interesting task as well.
Exactly. Okay, just for the sake of time, I'll move on. So this is like a very kind of an entry stage for a data set to just play around and see what's in it. But then we have Hugging Face, which contains a lot of helper scripts for interacting with the data. And all of these scripts are actually used in a Colab notebook that we've also released. So I'm just going to proceed to that Colab notebook for the sake of time. But obviously, if you just explore the GitHub and Hugging Face pages for Major Tom, you'll find quite a lot of helpful tools for working with the dataset. Okay, so I've already preloaded a Colab link, but basically, if you haven't, you just click on Open in Colab, and there it will load for you. You have to be signed in into your Google account, and basically you're good to go. Then you can use a GPU machine even if you want to do something more interesting with it. But here we're just going to load the main libraries that are helper scripts, and we will proceed with getting a copy of our metadata file. So basically loads it from our dataset page. It's about 170 megabytes. And if you load it, you can basically get all the information about Major Tom core, or hopefully any other dataset in the future when you get that metadata of that. Now, once we have that, we can use all sorts of filtering. And currently we support cloud cover, region, date range, and no data. So as mentioned earlier, we sometimes have tiles or like chips that have some part of no data. And in this case, we can show how to basically filter out like between 0% to 10% cloud coverage, a region which is a bounding box near Napoli, a date range for the last, I think, 5 years or 4 years, and then no data is basically not allowed in this case. And if we do that, we should get, I think, three different Major Tom samples. So that's about that, and that's how quick it is. And then we can use all sorts of helper functions to basically read a row. So like if we're interested in, let's say, band 4 and thumbnail, we can read that. And if we print that out, it should basically return a dictionary of the values.
Mm-hmm. So the data is just in a GeoPandas data frame, and you just got a helper function to help query that.
Yeah, exactly. I mean, we want to So basically, we want to see what people want, like what people are most comfortable with using in terms of like filtering metadata and so on. So we've been exploring quite a few directions for this, but so far we've just released like basic data scripts because they work fine. They're quite minimal. And then based on the feedback from the community, we can create different ways of interfacing with the data set. And then once we have this filtered data frame, we can just use the filter download function to basically create a local subset of the data set. So right now it's going to try to get all these 4 samples and create basically a directory structure just like the main data set, but it will only contain the samples we care about. I don't know if it's possible to actually see that on Colab, but it should be. So if we go to data, L2A, we have so this is basically the Major Tom grid cell that we have defined in our paper, and basically that contains a Sentinel-2B product, and that should contain all the TIFFs, basically in their original format. And once we have that, we can use the same directory to create a PyTorch dataset. It's a very minimal PyTorch dataset. And then again, we were thinking of different ways. I mean, there's Torgia who have done some really cool work on this theme. So we want to see what would be the best follow-up. So far, Major Tom is just like a local PyTorch dataset definition, but it's good enough. It's providing all the metadata and allows us to quickly iterate through the dataset. So we can, for example, look at the thumbnail, which is a pill image, quite quick to load. And here we can see the Bay of Napoli. So that's about it. There's also, we're planning to provide different ways and Hugging Face has this whole library of datasets, which actually allows streaming. So without any additional code, we can actually do this if it's being hosted on dataset. It will take a bit longer to first try to first basically check what the content of the dataset is. But once it kind of loads, it's fairly quick to iterate through, and it doesn't download the entire dataset. It just starts to iterate through the entire thing. Again, this is something we plan to maybe develop in various ways based on what people or we ourselves are looking for. So once that loads, we can get a sample from an iterable dataset, and then we can plot that sample, I hope, and it should be quite bright because our dataset starts at the South Pole. Like the first parquet is a South Pole, which is maybe something we should have considered earlier on to get something more interesting as the first sample of the dataset. But here it is, a white square, which is the first, which is the thumbnail of the first image. Obviously, we have the original TIFF file, so you can get some interesting information from that sample anyway if you're interested in that type of area.
Guarantee you're going to get issues about that. But anyway, it looks fantastic, and obviously all the building blocks are there to start using this data set. You've got a Torch data set. As you mentioned, it would be easy to integrate this into libraries like TorchGeo, for example. The code itself, the notebooks are on GitHub. The data set is on Hugging Face. I'm just curious if you can, describe what's on GitHub versus what goes on Hugging Face, because it seems the two are quite closely linked.
Yes. So Hugging Face is, first of all, we have the organization, which is not really associated with any specific repositories. It just links all the repositories that we release as organization. And we primarily use the datasets type of repository. So Hugging Face is mostly for raw data. We try to keep it as clean as possible. So if you go to like an example dataset, you just have the parquets. That will take a while to load. Okay, no, it's fine. You have the parquets, which is just the data assembled in the format that we discussed earlier. Metadata, and that's about it. There's also a README for the dataset card. So we're trying to focus on the data on the Hugging Face side, and then additional scripts for interacting with the data are here in our GitHub. Obviously GitHub is not suitable for large file storage, but we decided that the additional scripts could go here. So basically the kind of interface software side is on GitHub, and on Hugging Face, it's more about actually building new data sets, interacting with them, storing them, and maybe finding. So like the last bit from the notebook was this part, which is basically part of the Hugging Face infrastructure. So some additional helpers could go there, but only related to Hugging Face library.
Mm-hmm. I think in the future as well, the GitHub, for people who are looking at this, expect the GitHub to change quite a lot and for it to be quite dynamic and for lots of things to be added as we go. We're sort of hoping to basically keep the GitHub up to date with the specification of Major Tom as it develops. There might be data sets that aren't hosted on Hugging Face, for example. We're totally open to that because, Hugging Face is just one possible hosting platform that we've chosen to partner with. But, so all sorts of different kind of specification questions are going to arise on the GitHub. But for now, the Hugging Face page is kind of where the data is.
Okay, fantastic. Okay, so we'll put the GitHub link in the notes and the Hugging Face as well. And thanks again for the demo.
Thank you so much.
Okay. Thanks, guys.